Diana Hall is the founder and CEO of biomedical startup Active Armor, was named Colorado's Manufacturing Woman of the Year in 2022. She has degrees in chemical engineering and business from Colorado School of Mines and Colorado State University, and has worked in Fortune 500 companies in both engineering and software. Diana founded Active Armor in 2016 after running a non-profit for children in poverty and experiencing firsthand the problems with traditional casting. Traditional casts trap moisture and bacteria against the skin, spread viruses, and block basic hygiene practices like showering and sanitization of hands. Diana developed a patented process for digital 3D scanning, designing, and 3D printing custom casts that allow patients to live their active lifestyles while healing, improving safety and healing outcomes, and bringing casting technology into the 21st century. So Active Armor is now available in top hospitals and clinics across the United States and also in 11 other countries. Also, NFL players are currently wearing Active Armor on the field. How cool. So today, Diana's presentation is titled Mass Customization at Point of Service with 3D Printed Casts. Over to you, Diana. I'm going to stop sharing my screen.
Hi, everyone. Thank you for joining us. I'm wearing one of them now so that you can see them. I am going to present my screen so that you can see my content here, hopefully. Let me see. Share. Okay. Hopefully you can see my
screen. On up.
Great.
Wonderful. We're good to go. I'll turn my camera off.
Good.
Diana.
Okay, great. So I'm going to talk about the evolution to SaaS and AI, software as a service. So the evolution of manufacturing, first of all, we started out with low volume production where it was, one-off of standardized devices. And then we moved into mass standardized production, like assembly line type, which improved efficiencies, lowered costs. But again, you don't have the customization. And now we're looking at everybody wants custom design. So that's in custom products, right? And customization allows for so many new alternatives for each patient or each individual, whether they're in healthcare or whether they're consumers. And so you can tell that even by Starbucks, right? There are 56,000 different combinations of coffee that you can order. And so we went from centralized production, mass producing all of the pieces in one place, to outsourcing production so that we could get things cheaper and people could specialize in certain areas, and then on-demand fabrication, which has a local competitive advantage. In other words, if you produce a custom device on demand, it's going to be there faster and it can be customized for that unique customer. And that means that you're not going to have that competition with locations where they have or they have more efficiencies in acquiring their raw materials. And so now you have localized competitive advantage. And so with standardized designs, you'd have patents, right, of a certain design that now once you patent it, it becomes public knowledge, and then it's easily copied and made by other entities, and then your patents can be infringed upon, or you can have competition in the same space as soon as you make it public. Then there was the custom design options, which were very labor intensive because it required human interaction and trained labor to be able to recreate the custom designs for each individual device, or product. So it would require a lot of human interaction. Now we're moving into automation and AI of custom products. So that allows for speed, reduced labor costs, and it secures your IP. When you have a patent now, with AI and automation, you're basically obsoleting your own patent with every new piece of data that comes in. And so patents are becoming less useful in this space because they're obsoleted almost immediately with the emergence of AI. And AI and automation allows you to mass produce custom products at point of service. So all of these things working together enable the next generation of mass customization. And it also secures your IP, right? Because if your IP is in the software, it's not in a specific design, so it's hard to copy. So in healthcare specifically, healthcare is just ripe for utilization of AI tools and advanced manufacturing techniques, because there is no one size fits all in healthcare. We all have unique body shapes. We all have unique injuries or conditions that need treatment. So all kinds of diagnoses, and there also the needs for the custom products are urgent and timely. There's not I can just wait a couple of weeks to get something shipped to me from another country. It's more like, I need this right now and I need it custom, and it's urgent for a specific injury or condition. And so traditional methods are not working anymore, right? We have active lifestyles, especially during a pandemic. The inability to even just wash and sanitize your hands for weeks at a time while you're immobilized made no sense. So for me, going into the healthcare industry seemed obvious with my experience and expertise in 3D printing and software development, and AI just enables that even further. So all of the issues that you have with the traditional methods for immobilization, specifically spreading viruses, staff requirements for, and saws for cast sawing, and all of those things. Obviously this area was ripe for disruption. So when I looked into the space of where I wanted to focus my time and energy, I definitely saw the fracture care industry in healthcare specifically, not just for fracture care, but also for immobilization for a lot of different reasons. Diabetics, foot ulcers, and sport protective gear, veterinary applications, etc. This seemed like the obvious choice of exoskeletons for custom fabricated devices. So how I addressed the market demand was by having a 3D digital scan app that's available on any iPhone, and then developing custom designed software on the cloud that any one can access who wants to use that software, and then allow it to be cross-compatible with any 3D printing or honestly 3D scanning technology, so that anyone anywhere in the world who had access to a 3D printer of any technology with any material, as long as it's biocompatible, would be able to utilize this software design in order to fabricate custom devices unique for that individual on site in a matter of hours. So AI is the next generation of mass customization, in that you have unlimited customization options, and that you can use multiple materials, multiple designs, and that it can be uniquely specified for each patient. It reduces your time to the customer, because you're not making an entire mold and fabricating a bunch of them in bulk and then getting them to you. But instead, you can get them turned around at point of care in a couple of hours. Reduced cost for sure, because you're not, cutting it out of a big piece of plastic. You're not requiring molds. You're not requiring all of the things that it takes to fabricate custom devices in the past. And now with additive manufacturing, that's taking a lot of the time and cost out of it. And then the real-time product improvements. So every time you get more data input, you get a better product out, because it is constantly learning. So that really gives each country or each location a competitive advantage against any competitors that might be not co-located in the same geographical area. And then again, like I said before, that really has a strong effect on patents, because how valuable are patents when the AI software is continuously learning and changing and adapting. So that is all I had to share, and I would be happy to answer any questions that you guys might have.
Hi, Diana. Thank you for your insightful presentation. So I really liked, I guess, what you were sharing around some of the factors that influenced your work. A bit of a question, probably some people might think about this, some people might not. So obviously with COVID-19 rolling on through, and obviously that having a significant impact on sanitisation of hands, and obviously the ability to, put casts on and off, was there anything in particular that you did differently to help, I guess, users of the casts make hand sanitisation and cleaning easier? Is there any shifts you made as COVID came through to any of your products? Or any insights that you had along the way just in response to that pandemic, and did it alter your approach in some ways?
Yes. So the products themselves were in sanitizable plastic. So it was funny because COVID really emphasized we don't want to be transferring viruses around, and we want to be able to sanitize and, those kind of things. So it really just highlighted the seriousness of the need to change from the old school model of wrapping some fabric on your hand and not practicing basic hygiene like showering or washing your hands for weeks at a time. It really emphasized how important that shift to a digital alternative, how important that was. But for us, it changed our business model dramatically, because we had starting in 2020, we had no access to launching our new customers, which are hospitals, right? To go in there and physically show them how to do the scan, show them how to, do the entire process. We were blocked out from launching. And a lot of the hospitals were shut down. They weren't letting anybody in. They were stopping elective surgeries. Sports were canceled. So our main customer base too, because we're B2B and then B2B2C, right? And so both of those channels were cut. So we had to figure out how to improve our technology and even bring it direct to consumer in a way where they still need a prescription from their doctor, but they're able to do it through telehealth, right? And that's why we developed the iPhone app. So that anyone with an iPhone would be able to get the digital scan that they need and order from us, and then have the device shipped to them. Of course, as we move to our SaaS model where it's printed at point of care, that reduces even more barriers to entry, because now anybody can have access to 3D printed casts and in less time with less cost.
Awesome, thanks for that. I think this is a great segue to one of these next questions here from Carol McDonald. What scanner are you using, and is it on iPad or on the iPad or any phone? So I think if you can just extrapolate a little bit on the scanning technology and how accessible that is.
Sure. So we are cross-compatible with any scanning technology. However, we do have our specific iPhone app that is free to use. It's available on any iPhone 10 or newer. You can download the Active Armor Scan app and play with it. It's, like I said, it's free. So feel free to try it out. And you can use the iPhone, you can use the iPad, the structure sensor, you can use one of the big expensive scanners, you can use whatever you want. Like I said, it's cross-compatible. And I see your question about Android. Android does not yet have the correct hardware to implement our scanning application onto it. And so not Android, we're not looking at it yet. If they implement the new hardware, of course, we will adapt for that as well.
Awesome, thanks for answering that question. So if anyone's viewing and you've got a question, please put it in the Q&A. I'll be happy to ask that on your behalf. So another one from me, just for the interim. So obviously working in with medical professionals and in hospitals, it's a very fast-paced environment. And I guess technology adoption by different professionals in your industry, some find it easy, some will find it difficult. What have been some lessons learned or some big barriers that you've overcome in bringing this technology as an option? And so what we're talking about is bringing modern day casting into medicine. What are some successes and potentially some hurdles that you faced along the way?
Yes. So some successes have been that a lot of hospitals have, and I'm right now in Orlando at the IMSH conference, which is the Sim Center conference. So there are 4,300 folks here who are sim ops directors and people who are running the sim centers in hospitals who have a lot of them have 3D printers already, and their jobs are to incorporate simulation of medical models for surgical surgical guides and surgical models so that they can practice on the simulated organs before they get into surgery, et cetera. And so this is a great target market entry point for me because those sim centers would love to have a on 3D printing another product that's actually billable and can go into orthopedics, and it opens up a whole new market for them, and they are open to embracing new technology, which highlights one of the barriers that you were talking about, or that one of the challenges that I've had, and that is bringing a new technology into an old school market in a very risk averse market of healthcare, right, and orthopedics. They've been doing the same thing for 200 years where they get some fiberglass or plaster out of the drawer and they wet it and they mold it onto your arm, and then they wait till it dries, and then you walk out and then you can't see or observe or clean or do anything, and then you come back in and they saw it off with a saw and for every exam and x-ray until you're healed. So that's their standard way that the culture and the way they have the entire clinic flow set up. And so to try to put a digital technology into that flow has been a challenge, right? To a lot of the old school mindset is, some of them can't even use their smartphones yet. And so to incorporate a new technology into that healthcare market has been a challenge. So going in through these sim centers is great. And also we've gone in through sports medicine. So high-end sports medicine doctors, we contracted with the NFL, the workers' comp group for the NFL right away. And we have, like you said earlier, we have players wearing them on the field. So sports medicine providers really get it. They see the benefits for their patients. They can ice bath with it. They can use bone stimulators. They can use next gen healing products with it because they're all custom accommodated for implementation of those advanced healing technologies. So they really understood it. So our target market as a market entry strategy was definitely in sports medicine and in these sim centers and innovation labs in the hospitals. Oops, I can't hear you.
Sorry, awesome. I just realized, sorry. Look, we've got a couple of other questions here from Carol. So obviously influenced by, I guess, your work with youth and children's casts, do you do some like kid-friendly designs like with cats or dinosaurs, or can you put that kind of stuff into the cast as well?
Yeah, so the designs are done, again, it's automated based on giving you the most breathability while maintaining the basic structural integrity that you need for strength of the device. So the patterning, and as well as offsetting any bony protrusions, pins or incisions, making the exposures that you need for advanced healing technologies, et cetera. So the design of the patterning is defined by function more than form. However, we do custom logos on them, custom patterns. You can, do hydro dipping. You can do all kinds of cool colors and cool designs and all that kind of stuff on them. So yeah, and we are contracted with multiple children's hospitals. So yeah, definitely it's kid friendly. Parents love it, and you can definitely customize it.
Yeah, nice. And if I ever break in, I'm going to come and see you and get one with like a cat printed into it as well, or a little rocket or something.
Sure.
So I think we've got one more kind of question here from Carol. And thank you, Carol, for all of your questions. You've asked some brilliant ones. So the software is parametric and is dependent on the patient's body shape. Are there different guidelines dependent on type of break or different medical conditions? Great question.
So yeah, good question. And that's part of what the AI, the implementation to the software is about, right? So they'll put in the diagnosis code and then they'll pick the device. So for example, for a scaphoid fracture, you will normally select a thumb spica, and then it will be, okay, so dependent on where the fracture is, how far up the thumb will you want to mobilize? Will you want the MP joint, just the IP, etc.? And so the AI will incorporate the diagnoses, but again, every patient is different. So it's not going to put a design on there that your doctor does not have any autonomy over. The doctor can then make any changes that they want to the template that comes up for them. So, for example, the thickness, like if it's an old lady knitting who, has a device, or if it's an NFL player going to be bashing helmets, they're going to want a different design, even if it's the same injury, right? So that gives the doctors autonomy to be able to make those changes. But it does offer you templates and options that they can choose from, and guide, especially in casting techs and ortho techs and everything. It's definitely a tool that they can use to improve the speed and the quality of treatment that they offer their patients.
So I guess another question from me. So where to next for Active Armor? Like what are your next steps as an organization, as a business, in relation to technology or in relation to growth?
Yes. So we actually have a fundraising round open. It's a pre-launch round for our software as a service transition. So for the first phase of our company, we have done centralized production where people can scan anywhere and then we ship the device to them, but that added extra cost and a delay in receiving the device. So now we're moving to completely software as a service company where we're providing the custom design services so that anyone anywhere can fabricate on site in a matter of hours the custom devices. So if you know of any accredited investors who are interested in investing, we have a 506c round open right now, pre-launch for this new business model. And the next generation is going to be the incorporation of adding all of our data into an AI functionality, again, to provide templates for providers to use for developing the CAS in ideal scenarios, and while giving them still the ability to customize those templates as well. So that's the future. And then we also have other product lines coming down the pike. We have, veterinary applications. We already do a lot of sport protective gear for athletes. And then we can also do, we're looking at body armor applications and other exoskeleton designs.
So cool. So cool. And just out of intrigue, so you obviously got your cast on your arm. Can you potentially show us how easy or how tricky it is to take it on and off? Just, if you were a user of it. I think it's
so
quite
doctors have two options. They can lock it onto the patient like this if they want it to be like a cast, so that the patient's locked in. But it's still adjustable for swelling. You can bivalve and add spacers anytime that you want to accommodate for swelling and or tighten it up at any time. That said, I have mine as a splint. It can convert from a cast to a splint at any time. You can just pop it on and off. You can add these bungees, these little bungees with toggles anytime, and just slide it on and off just like that, and then put it back on at your convenience. And again, it's fully adjustable as well. So, if you want to add space or remove space at any time, you can definitely do that. It's easy, depending on whether the doctor wants you to use it, like a splint, or have it be removable, or transition from locked on to removable through the healing phases.
That's really, really cool. Thank you for sharing that. So what we'll do, any other final questions? Just welcome one last round for any questions into the Q&A. Otherwise, what we'll do is, I think, Diana, thank you so much for sharing, your story about Active Armor, the work that you've been doing in bringing casts to, the US medical industry, and also those other countries which are now expanding to, and sharing about, what's coming up next. And I found it really insightful. So honestly, I'm going to be hitting you up if I know anyone that has a broken bone next time.
Thank you. Happy to help.
Lovely. Thank you so much.
Bye.